This video is on the objective graph a rose curve from a polar equation. All right, and this is the second video on this objective, so I'm hoping you watched the first one. And let's just take a look at the question. And again, if you want to see more on the objective, just go to the bottom, click on More Instruction, look at their videos, their notes, their examples, and hopefully those help you. Alright, so we have r equals some number times the sine of 4 theta. This is going to be one of those rose curves. So remember, the rose curves looked like this in general. You had r equals some number times the sine of n times theta, where n is an integer, a whole number, or cosine. It could be cosine as well. And here we have r equals -3 times the sine of 4 theta. So remember, when n was even, which it is here, right, this 4 theta, you had 2 times that many petals in the rose, right? So this is going to be a rose curve with 8 petals. Right? And when the number was odd, it was, a rose curve with just that many petals, right? If that was 3 theta, it would just have 3 petals. All right, so let's see this happening. Now, you've seen other videos where I've been graphing polar curves on the polar grid. First, I like to look at what I call, the XY version, not the rectangular. I'm not converting this to rectangular coordinates. I'm just replacing r with y, replacing theta with x, all right, and graphing it the way I normally graph a trigonometric function. So again, x represents values of theta, y represents values of r, all right? And this would have a period of pi over 2, right? It'd be 2 pi over 4. So here's, pi over 2. And then to get to 2 pi, I'd have to do this 4 times. So I'll basically be getting 4 copies of the graph. There's pi, here's 3 pi over 2, and here's 2 pi. And here's one period. I'm going to break this into quarters. Right? There's no phase shift, right? So that's why I'm starting at 0 here. No phase shift. And a quarter of this is every pi over 8. Right? So every pi over 8. So there's pi over 8, 2 pi over 8, pi over 4, 3 pi over 8, 4 pi over 8, and so on. And here's 5 pi over 8, 6 pi over 8, 7 pi over 8, 8 pi over 8, and so on. Then the amplitude is going to be 3, right? I got 3 up here, -3 down here, and sine of 0, 0. And when I plug in pi over 8, I'll get -3, then 0 at pi over 4, then 3 at 3 pi over 8, and then back to 0. And here's one cycle, one period of the function. And then this picture is just going to repeat over and over again, right? Here, 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 here. And then 1, 2, 3, and then this is a 9 pi over 8, 10 pi over 8, 11 pi over 8, 12 pi over 8, and then here, 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 here. Just keep repeating this picture, and then 1, 2, 3, and then 13 pi over 8, 14 pi over 8, 15 pi over 8, and finally 16 pi over 8. And I get this picture, 4 cycles. Now, we're probably not going to have to go through all 4 cycles to see the full graph, but, well, let's take a look. So I'm going to use this graph from 0 to 2 pi to take me, once around the polar grid. So I'm going to draw a polar grid. So you got the vertical axis, means really nothing, it just breaks things up into quadrants, and then you got your horizontal axis, which is the polar axis. And I'm noticing here, right, the largest r gets, right, the largest y gets here is 3, right, and the smallest it gets is -3. So the furthest any point is going to get away from the origin is 3 units. So here's r equals 1, r equals 2, and r equals 3. And I'll draw this circle. I'll draw a circle here with a radius of 3 centered at the origin. So there's this circle. This is not great. Right there. There's a circle with a radius of 3 centered at the origin. And then another thing I'm going to do is break all the quadrants up into fourths. See, every pi over 2, here this positive polar axis corresponds to theta equals 0. The positive vertical axis corresponds to theta equals pi over 2. And remember, that was a period, and I broke this up into quarters. So I'm going every pi over 8. So here's half, and then half of that half, half of that half. And I'll do the same thing for every quadrant. Right, break every quadrant up into quarters, get all these pi over 8s. So this represents, pi over 8, 2 pi over 8, pi over 4, 3 pi over 8, and so on, all the way down to 2 pi, right? All the way around to 2 pi. All right, now what I'm going to do is, again, use this graph up here, where, again, remember, x represents values of theta, y represents values of r, to help me draw this graph on the polar grid. Alright, so this first part of this graph up here, well, I'm starting at 0, 0. Anytime I'm on the x-axis up here, that means y is 0 or r is 0, and that means I'm at the pole. Right? R is 0 means I'm starting at the pole. Now, from 0 to pi over 8, that's between these two lines. Well, it would be, but I have negative values of r. So if I had positive values of r, I'd be between these two lines. But because I have negative values of r, I'm going to be on the opposing side in quadrant 3 here, right? Looking at the vertical angle, right? I'm between these two. I'm going to make my graph between these two lines. And I'm starting at the origin, and I'm ending at the circle with a radius of -3, or I'm ending on that circle with a radius of 3. So starting at 0, ending at pi over 8. So starting on this line, so starting here, ending on this line corresponding to pi over 8, I'm going to end here on the circle with a radius of 3. And make it curvy. Don't. So like something like this. And that'll be like half a petal. Alright, that's half a petal. Alright, and then from pi over 8 to pi over 4. Right, so between here and here, pi over 8, these two lines. Again, I have negative values of r, so instead of being between these two lines, I'm between their corresponding lines on the opposite side, right, on quadrant 3. And I'm going from a radius of -3 back down to a radius of 0. So between these two lines, I'm doing this, going back to the origin. There's the rest of that first petal. Right? This is one petal. And there are going to be 8 of these things. All right, so that took care of this part. All right, then this part, between pi over 4 and 3 pi over 8, so between here and here. Now I have positive values of r, so I will be between here and not the opposite side. And I'll go from 0 to 3, right? Radius of 0 to this point out here, radius of 3. So, and then from here to here, 3 pi over 8 to pi over 2, between here and here, going back to 0, right? Back to a radius of 0, finishing that petal. So here's another petal, 2 petals. All right, now, between pi over 2 and 5 pi over 8, that's between here and here. Well, It's not going to be between here and here because I have negative values of r, so it's going to be between here and here on the opposite side. Starting at 0, starting at the origin, going to negative 3, so we're doing this half of the pedal. And then between here and here, the other half, which is really between here and here, right? That's taking me back down here. All right, then between 3 pi over 4 and 7 pi over 8, between here and here, I have, positive values of r, so I am actually going to graph between here and here. And I'm going from 0 to 3. So 0 to this point here. 0 to that point there, and then coming back between here and here, there's the fourth pedal. All right. Now there is some symmetry involved. What you're going to see is I'm going to take this picture and flip it and get the rest of it. So I promise you it's going to look like this. That one reflected over. This one reflected over. This one reflected over. And this one reflected over. And you could test it out by going through the rest of this graph, going, because I went to pi, go from pi to 2 pi. That'll be the reflected version. And here's this graph: 8 petals, 8 petals, and every single petal is, the edge of it is on this circle with a radius of 3, right? The length of every petal is 3 units. All right, so let's see that actually happening on this Desmos website, right? A free online graphing calculator, desmos.com. I'll put in r equals the negative 3 times the sine of 4 theta. You can just type in the word theta and look at that. There's your rose curve with 8 petals. And just to show you that none of the points are further than 3 units from the origin, I'll just put in r equals 3 for this circle. Right. Wonderful. All right, and then back on the problem, we just have to pick the correct one. This one has 8 petals, and it looks pretty good. Right? It looks like the graph I made, and every point on the end of a petal is on this circle with a radius of 3. I think this is it. Let's check the other ones. Definitely not, definitely not. This one has 8 petals, but it's not the correct orientation, right? Look at my picture. Look at my picture compared to this one. See how, the polar axis kind of cuts through some petals, right? It separates 2 petals. Whereas in this picture, the horizontal axis, the polar axis, is actually cutting through petals, cutting petals in half. That didn't happen in my graph. Also, these points on the end are further than 3 units away from the origin, so I can tell that's not it either. So the one I selected, it's got to be the one. Right? Okay. All right. So again, hopefully, watching me do this, playing around on the Desmos website. You could also just go to the Desmos website, enter this equation, and see what it looks like. You don't have to really graph these by hand. I just want to kind of show you, how to graph them by hand if you needed to. And also, look at the more instruction when you need to. Read the answer explanations when they come up. And I'm hoping all this stuff, right, helps you out when you're working on this material on your own. And thank you very much for watching.